Hello guys, what's up? Welcome back my channel, The Learning Destinations. I'm your host Avinash. Guys, today I'm going to cover a very interesting topic, and the topic is chaos engineering. Guys, under this sections we are going to understand each and every phases of chaos engineering. We are going to deeply dive under this concept, chaos engineering. We will see that how we can handle the failures before it becomes outage on the production grade system. So we are going to learn many more about chaos engineering under this section. So just stay tuned, sit back, relax with me and enjoy this journey. Also, I would like to request for all the first time visitors who are visiting first time my channel, please subscribe my channel and press the bell icon as well. Hey guys, so now I'm going to take you directly on the definitions of chaos engineering. But before I explain it, let me tell you one thing. So nowadays, how do we test our applications? How do we test basically our codes? So firstly, whenever we build any application, we first test on dev environment. After that, we take it on a stage, and then finally we test it on UAT. If it passes all the tests from dev to UAT, then finally we move our code into the productions level deployment, right? But generally, many times it happens that whenever we move our code on the production level, it gets fails. No matter it passes all the tests on the dev stage and UAT, but still we won't get the desired output which we have received under these three stages of testing, dev stage and UAT. We don't get it on the productions level, right? So mitigate this kind of risk. In order to mitigate this kind of failures, there is a term introduced that is called the chaos engineering, where we directly do the testing on the production grade system, and that is what we are going to talk about today in this session. So basically, chaos engineering is a practice discipline where we perform software system testing experiment directly on the productions in order to build system capability to hold up churning and unexpected conditions. So that is the definitions of the chaos engineering. Okay, so we have just now seen the definitions of the chaos engineering, and we can also see the chaos engineering as a preventive and proactive action. So chaos engineering is a proactive approach to identifying errors before they become the outage. So guys, generally we test the software development from the dev stage, UAT, and then finally we move it onto the productions. But sometimes it happens, the last moment surprises happens, which totally impacts on our release date, which totally spoils our effort, right? So that's why we need to build some systems where we can directly test it on the productions level system, and that's what that it is, the more preventive and proactive actions, and that facility is given by the particular chaos engineering, or we can say that chaos engineering makes it available the such facility where we can test our software directly on the production grade system, so though there won't be any last minute surprises, right? It is proactively actions to test software system under stress. It is one of the smart ways to identify the failure before they become outage and bring your system down, right? So let's suppose that something we build, we implement on the production level, and then after that if it gets fails, it may be the outage. But in such scenario where we can directly test on the productions, and if any failure occurs, we can tackle on the same time. It means we get to know about the system behavior on the productions itself, right? There will be a very less probability for the outage, and that's what the particular chaos engineering gives us the facility. So now I'm going to talk about some principles of chaos engineering, and it is pretty much simple. Plan theoretical experiment, try to find out the maximum result for outage. It means that you create the hypothesis, you check out that what are the regions that your system may get fails, right? After that, you prepare your test, execute it, and observe the system behavior. You keep trying it until you get succeeded, right? So let's suppose that in a starting moment you are creating only 3-4 cases, right? Then if it gets succeeded, then you create the plan, again you create the hypothesis, and after that you observe the system behavior. Then next time you plan for 10 cases, 15 cases, right? You think from each and every corner that what are the circumstances your system may get failure, right? And continue testing. So that is exactly the chaos engineering principles. Okay guys, so far now we have seen the definitions of the chaos engineering, and after that we have also understood the chaos engineering from the preventive and proactive action point of view, and then finally we have understood the principles of chaos engineering. Now I am going to tell you about way of perform chaos engineering. You might be wondering that how exactly the chaos engineering can be performed, right? And now I'm going to explain this one. So there is some circumstances, and after this slide I have kept one of the example through the MySQL database where I am going to explain you the entire chaos engineering basis of these circumstances which I have listed on my screen: known knowns, no unknowns, unknown knowns, and unknown unknowns, right? So if still you are waiting for better understanding on the chaos engineering, after this slide your concept will be completely clear, because I am going to explain it by giving one of the example. But first let's understand it. What are the situations where and in how many types we can perform the chaos engineering, right? So first case is no knowns, where you are aware the impact of the things, right? Something happens wrong, some failure happens, you know that okay, it is going to be definitely happens, and once it happens, then after that this process will be automatically happens, right? So this is called no knowns, where you are aware the things and understand it. Next situations you can perform known and unknown. You are aware but unable to understand completely, right? So you know that okay, if some replica is going down, right, definitely it will be removed from the clusters, but after that the next process you are not understanding. There is another way called unknown knowns, where you understand but not aware of. It means that you understand but you are completely unaware that what will happen after that. And then there is a situation called unknown and unknowns, neither aware, even you are not aware, not fully understand. Okay, so these are some circumstances. By following it, you can completely do the testing under the chaos engineering, or you can create the chaos engineering environment for better understanding on your product failures. And in my next slide we are going to understand it more closely. Now this slide is going to be a more interesting, and for those who haven't yet completely understand, now you will have the complete understanding. So basically on my screen you can see that there is a two reason A and reason B. There is a database cluster. So there is a one primary DB and there is two set of replica in each of the reason, right? So let's talk about the know and knowns. The first circumstances where we can create the chaos engineering environment, we can perform our testing under the chaos engineering. So let's first discuss about know and knowns. So in know and knowns, what will happen? Let's suppose that when a replica shut down, it will be removed from the cluster, right? So this is no condition. So let's suppose that this replica is getting down, sorry, right? It will be automatically removed from the cluster. Okay, and after that we know that a new replica will then be cloned, right? So definitely, since it is running in a cluster, there will be a replacement for this replica, right? So this matching the conditions that know and known. So we can we can check the system behavior once the replica is completely getting shut down, right? So there we can observe the system behavior, and once the replica is replaced by the another replica, right, we can see the how much time it is taking, and how is the read write IOPS speed of our database when the one replica is working, right? So this kind of testing we can perform. I'm just giving you one idea. So this is one of the case where know and knowns, in such circumstances we can simply check it, right? We can simply absorb it. After that, then it comes know and unknown, right? So in know and unknown, we know that the clone will occur, right? As we have logs, definitely we can see that, right? So there is one of the replica, if it getting shut down, right? So it will be replaced by the another replica, that we know, and we can get it this confirmations by the system logs, right? So those who worked on the cluster, they definitely know once the one of the replica goes down, and once it comes, we can always track it in the logs, right? So but let's suppose that if it happens weekly, so we can take the weekly average of the mean time it takes from the experiencing a failure to adding a clone back to the cluster effectively, right? And we know we will get an alert that the cluster has only one replica after 5 minutes, but we don't know if our alert threshold should be adjusted to more effectively prevent incident, right? So this is the called unknowns, right? So we know the cases where it is getting replaced by the replica, right? But we don't know if it happens weekly, then how much time it takes from one replica is replaced by the another, and simultaneously how soon our alert manager can trigger it, and if there is any threshold between the alert manager. So this is the second case where I know some of the cases known, and but about the alert threshold value, how frequently it happens, within how much the second replica will be up, these are the unknown circumstances that we don't know, right? So now I'm going to talk about unknown and the so guys, now I'm going to talk about unknown and known. So let's suppose that so there are two environment, region A and region B, but in region A this environment is completely going to be shut down, right? So that we don't know what will be the impact, but here what we know is we have the another region set up, right? So if transactions get stopped because of it is going completely to be shut down, right, still it will be the applications will be functioning because we have the same replica in another region, and in terms of failure of this region, right, it will be complete transactions will be keep going through the different regions of setup, right? So this is a case of unknown and known, and in such cases when this entire setup is going down, it is shut off, right, shut down, then you can completely you can observe the system behavior and accordingly you can do the testing, right? So this is the case of unknown and knowns. I'm going to talk about unknown and known. So in the previous unknown and knowns, we have seen that if we shut down the entire this region, right? So we have another region B, we have another setup which keeps performing the transaction, right? In unknown, what will happen? Let's suppose that this entire setup is going down, we are going to shut down this entire setup, right? But since we haven't yet performed the testing, in such cases how the region B setup will behave, right? So this will become unknown also, whether it will be functional in case of if this will be going completely down, whether this will be functional, operational or not. Since we haven't performed the test, we don't know its characteristics, right? So this is the case of unknown and the unknown, right? So in such a way, on the basis of known unknowns, known unknowns, unknown knowns, unknown unknown, right? On basis of this, you can simply check the system behaviors and you can follow each and every parameter of chaos engineering, and you can make and perform better robust testing for your product. That will never going to be a fail if you do such kind of regressive testing under the chaos engineering. Okay guys, so now let's talk about the benefits of chaos engineering. So there are many benefits of chaos engineering, but some of them are very popular, which I'm highlighting here. So you can easily identify the weakness in system through controlled experiment that introduce random and unpredictable behavior. Identify vulnerabilities before a hacker does or before a system failures. Guys, there are many tools available in the market. By using it, you can simply follow the chaos engineering principles, right? So the famous tools are Chaos Kong, Chaos Monkey, Chaos Gorilla and Latency. And guys, if you know that if you go in the history of chaos engineering, which I haven't covered because that was not that much I can say that was not much topic, that's why I haven't cared but covered. But just for your knowledge, basically the chaos engineering was started by the Netflix has implemented and worked much on chaos engineering. So if you have time, just go on the internet and check it. Okay, so I'm not going in depth of these tools because this is a study of another topics which I'm not going to cover, because my main topic is to highlighting and introducing you chaos engineering. So what are the companies that using chaos engineering? Guys, there are many MNCs who is following the chaos engineering, and few of them which are very popular: Netflix, Facebook, LinkedIn, Google. There is Twilio. There is I guess IBM is also following. So there are many more companies. Those are following the chaos engineering. Hey guys, so that's all for the day. I hope you really enjoyed this sessions, and if you have any questions, please feel free to reach me. Just write me in the comment sections and I will answer it there. Also guys, please don't forget to subscribe my channel and share it with your friends and the colleague. I will see you in my next tutorial. Till the time, thank you so much for watching this, and please don't forget to subscribe. You have a very lovely and healthy day.